Okay, problem 10 says a root of a function f of x is negative 1 minus 2i, which could be an equation for this function, and we're given a few options here. Okay, so we want to figure out which of these four equations has as a root or as a zero this negative 1 minus 2i. Okay, there's a couple of ways we can figure that out. First one's going to be actually taking this root and coming up with the function. Okay, and a few things going on here. First of all, if I know that x equals negative 1 minus 2i is a solution or a root of the equation, I also know that x equals negative 1 plus 2i is a root as well. Okay, that's coming from something called our conjugate roots theorem. The only way I can have square roots or i's, okay, imaginary units, which is where square roots come from, is if I have both the plus and the minus. Okay, now if I set both these kind of expressions equal to 0, we end up with x plus 1 plus 2i is equal to 0. That would be a factor of my function. And same thing, x plus 1 minus 2i equals 0 would also be a factor. So what I can do then is I can say my function f of x is equal to parenthesis x plus 1 plus 2i times x plus 1 minus 2i. Okay, that's in factored form. Now if we distribute things out and put it in standard form, we'll be able to tell which of these four functions it is. Okay, to do that, I have to take each part of my first binomial, multiply by each part of the second. So we'll start off with the x times x, which will be x squared. Okay, x times 1 will be plus x. And x times negative 2i we'll just say is negative 2ix. We'll do the same thing with the 1. X times 1 again will be plus x. 1 times 1 will be plus 1. And 1 times negative 2i we'll say is negative 2i. Then we'll go through that process one more time with the 2i in the first factor. 2i times x will be plus 2ix. 2i times 1 will be plus 2i. And then 2i times negative 2i will be a negative 4i squared. Okay, from here we can simplify that. I'm seeing one part with an x squared in it. I'm seeing two parts with plain x's. There's an x plus an x, we'll say plus 2x. Okay, then as far as my pieces with i's in them, I'm seeing a negative 2ix and a positive 2ix. Those will cancel. I'm also seeing a negative 2i and a positive 2i. Those will cancel as well. And what we're left with then is a 1 minus 4i squared. Remember, when we have I squared, that's equal to just negative 1. So really we have a 1 minus negative 4, in other words 1 plus 4. Okay, so plus 5 at the end here. Okay, so it looks like option D is going to be our solution to, our function with this as its solution, with this as its 0. Okay, like we said, that's one way to go through it. Now if you're uncomfortable with that, if you're forgetting about how the conjugate roots theorem works, the other thing I can do is take these four equations and actually solve them. Okay, figure out what their zeros are. So what I could do is we'd take them one at a time. I'm just going to skip ahead to the one we know the answer is. If I have x squared plus 2x plus 5, we're talking about roots, so we're looking at where that's equal to 0. I can use the quadratic formula on this with my a equal to the 1 out in front of the x squared, b equal to 2, and c equal to 5. So my quadratic formula then says that x is equal to the opposite of b, so negative 2, plus or minus square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is 5, all over 2 times a, so 2 times 1. Okay, reducing that, we'll start off with a square root, so this will be negative 2 plus or minus square root of, so we have 2 squared is 4, minus 20, so negative 16, all over 2. Okay, so we can say then x is equal to negative 2 plus or minus, okay, the square root of 16 is 4, but with this negative we're going to say 4i, all over 2. And then our last step here, negative 2 divided by 2 is negative 1. 4 divided by 2 will be 2. So we have a negative 1 plus or minus 2i. And what we see here is we get with the minus the same root we started off with. So that way it would take a little bit longer, but if we go through these equations one at a time, we'll figure out which one gives us the correct solution.